Hello everyone, this is Ketish here. In this video, I'm going to go through question number 5 from the AQA 2021 Combined Science or the Trilogy, Paper 1, Physics, Higher Tier. Question number 5 is on the topic of electricity. A TENS machine uses an electrical current to relieve pain. Figure 8 shows the electrodes of a TENS machine connected across an ankle. So you can see the machine here and the electrodes which is being connected. The maximum power of the TENS machine is 240 MW, stands for millivolts, not mega. It's a lowercase m. So it's millivolts, milliwatts. The potential difference across the battery in the TENS machine is 2.5 volts. Calculate the maximum current from the battery. So what is the equation that links power, which is P, to potential difference, which is V, and to the current, which is I? The equation that links all three values is P equals VI from the equation sheet. So power is 240 milliwatts. Now you'll have to change that to watts. How do you change that to watts? You divide that by 1000 and that gives you 0.24 watts. That should generally give you 1 mark for the conversion. So 0.24 watt equals, the potential difference is 2.5 multiplied by the current. Rearranging the equation, I equals 0.24 divided by 2.5, and that gives you an answer of 0.096 amps. So the answer is 0.096. So for the 4 marks, 1 mark for the conversion, 1 mark for the substitution, 1 mark for the rearranging equation, and 1 mark for the correct answer, or you get all 4 marks if you simply write down the correct answer in the line. Next question. Figure 5.2 is a sketch graph showing how the potential difference across the electrodes varies with time. So you can see the potential difference on the y-axis and the time along the x-axis, and the line for the graph is going on the positive side. So that's the positive values, that will be the negative. A student concluded that there was an alternating potential difference across the electrodes. How does figure 9 show that the student was not correct? Now, if it was alternating, the direction of the potential difference should actually go from positive to negative. So the graph should actually look like this. So positive and negative, that will be 0. The graph should actually go. Oops, what's happened to my, oh, there you go. What's happening there? Right, let me draw it there. So the graph should actually, the diagram doesn't want to stay. Oh, there you go. Right, so the graph should actually go in that way, because the lines are always going in the positive side. It's not an alternating current, but it's a direct current. So how does figure 9 show that the student was not correct? Because the potential difference is always positive, or stays always positive. Figure 10 shows a circuit that the student built using the battery from the TENS machine. So you have a power supply here, That's the power supply. And a variable resistor, a fixed resistor, a voltmeter, and an ammeter. The student recorded how the current in the resistor varied with the potential difference across the resistor. So they are measuring how the current changes with the potential difference across the resistor. So they're measuring the readings from the ammeter and the voltmeter readings. Figure 11 shows a sketch graph of the results. So generally you will see graphs which is on the positive side. Here, when the graph, what looks like an upside down graph, is actually missing this bit, right? So if the graph was actually has the positive side, they're missing this section. They're only showing you the negative values for this. That's why the line is going down here. What relationship does figure 11 show? Because it's a straight line going through 0 and it's at 45 degrees, right? So it's not at an angle like that or like this, right? Because the line is actually in the middle, it's a directly proportional relationship, right? So it shows that the potential difference is directly proportional to the current. Next question, 5.4. Figure 12 shows two more circuits that the student built using the battery from the TENS machine. So you have a series circuit here. So this is a series circuit, which is circuit A. And circuit B is a parallel circuit. The resistors all have the same resistance. So they're talking about the same resistance in both, all three of them. If I write it as R, and R. Compare the readings on the voltmeter and ammeter in circuit A and circuit B. So first, they're asking you to compare the reading on the voltmeter. What will be the voltmeter reading in here? So let's say they both have 9 volts power supply. If it's 9 volts there, because it's only one component, you are going to read 9 volts there as well. Now, because it's a parallel circuit, you're going to read 9 volts across each of the components. So it's going to be 9 volts across this resistor and 9 volts across this resistor as well. If it was in a series, if the resistor was in here, then you could say the potential difference is going to be split. But in this case, it's just one resistor. So let me get rid of that drawing. So how do you compare the voltmeter reading? The voltmeter reading in circuit A is going to be the same as that in B as well. So the reading is the same in both circuits. What about the ammeter reading? Now, the ammeter measures the current. There's only one resistor here, so it's going to give you a certain amount of reading. What happens to the current if you attach another resistor in parallel? Now, what you need to remember is what happens to the current if you attach another resistor in series here again in circuit A. Well, if you add two resistors, the overall current actually goes down if it's in series. If it's in parallel, it's actually the opposite effect. The overall resistance actually goes down because there's two paths for the current to go through. So the overall current actually goes down. So the current in A is going to be less than the current in circuit B, because the overall resistance in circuit B is less. So the current in circuit B is twice the reading of circuit A. So here you'll have to mention that it is twice, hence that's why it's 3 marks. So you'll get 1 mark, and you get 1 mark to mention this, is that it's twice, because they are identical resistors, right? The resistance is going to be halved. The reading in circuit B is twice the reading in circuit A, but if you simply mention that the current or the ammeter reading in circuit A is going to be less than circuit B, you'll only get 1 mark rather than 2 marks. So this actually gives you 2 marks. That brings us to the end of question number 5, and I will see you in question number 6.